Bonjour and welcome to Wahsa Distance Education's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. In order to participate live, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM. Television at Bell Express View, channel 972. You can always join me live through Zoom. The link is available through me, your teacher, and also your DEC. Our classes are scheduled from Monday to Thursday from 11 a.m. till 12 p.m. And we are in our third week of our 9-week course. A reminder of what work to submit for marking. The support questions, the ones marked with the pencil icon, are not for marking. They are just the practice questions for you to get comfortable with the material. You decide which ones and how many of them to do. If you understand the concept, feel free to skip questions. If you need more practice, let me know and I can send you more. The answers are in the back of your booklet, so please check your work to make sure you're on the right track. However, there have been mistakes found, so if anything isn't lining up, let me know and we can check them out if there's mistakes. The key questions, the ones marked with the key icon, are the marked questions, the ones to submit. So please do all of them, as well as showing all of your work and your steps and your thinking. If you make any errors and you only give me the answer, I can't give you credit for the parts that you do understand. So please show me everything. How to submit your work for marking? There are 3 methods. The first is to scan and send your work in electronically. You can scan your completed work through the iPhone Notes app or through the Android Google Drive app. If you need help scanning, let me know and I can support you. Then you can email it to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. Second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street at our side entrance. We're the big red building next to the post office, and there's a small mailbox next to the side entrance. Because we're currently working remotely, it may take me a couple of days to get your work, but I will get it and get it back to you as soon as possible. The third method is to hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Always, if you have any questions or concerns, please contact me. My email is bronwyn.slate, which is spelled BRONWYN.SLATE @nnec.on.ca, or you can Facebook message me at bslatewahsa. You can call the main office and leave me a voicemail or a message with the front desk at 807-737-1488 or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., and I'll get back to you as soon as I can. Connecting with me through social media, you can friend me on Facebook at bslatewahsa or subscribe to my YouTube channel at bslatewahsa. All of our classes are, after they're aired, are uploaded to YouTube and I share them on Facebook. So that's a great way to access the replays. There are also short videos explaining confusing concepts or common errors on my YouTube channel. So it's a great place to access resources if you're struggling with concepts. Math is a very visual subject. So connecting with the replays or the videos is going to set you up for the most success. Either joining us live or going to YouTube and watching the videos. So please try to do that if you can. If you don't have access to the internet, but you do have access to a computer, let me know and I can send you a USB with all the recordings. All right, we are in day 10 of our course, and today we are diving into lesson 7, which is compound interest and exponential growth. Our learning goals are such that at the end of this lesson, I will be able to calculate the final amount when an investment or a loan's interest is compounded. and I will understand the relationship between compound interest and exponential growth. Success criteria. So you know you've met these learning goals because 1, I can identify the principal interest rate, compounding periods, and the time in order to find the final amount. And 2, I can graph compound interest growth. All right, let's activate our brain with some mental math. So instead of doing mad minutes like many of us experienced in elementary school that were boring and horrible, made lots of people experience anxiety, math anxiety, and didn't actually teach us any skills, we are focusing on developing transferable skills that we can use in multiple situations. Today's question is 68 divided by 3, and we're going to use a strategy of multiplying up. Division is, many folks do not like division or really struggle with long division. So having multiple strategies is really useful. So instead of dividing, we're going to multiply up to our product, to our answer. So instead of figuring out what 68 divided into 3 groups, we're going to say 3 groups of what figures out to be 68. So we're going to, as always, use friendly numbers that are accessible to us. So I'm going to think of, okay, well, 3 times 10, so 3 groups of 10 is going to be 30. Okay, so that's not high enough, so I'm going to need more groups. So 3 groups of 20 is 60. Okay, so that's getting me closer to my 68. So I'm going to still need more. Okay, so I can think of, okay, 3 times 21 is going to be 63. I still need more because I'm getting up to 68. So 3 times 22 is going to be 66. I haven't reached 68 yet, so I'm going to keep trying. 3 times 23 is going to be 69. Oh, that's more than 28. So if I know that it's going to be 3 times 22 and some. So if I do 3 times 22, that gives me 66, which means that I have 2 left over, right, to get 68. So my answer is going to be 22 with a remainder of 2. We could do fractions or decimals, but we're just going to leave it as a remainder right now. So that's another method of dividing, is using facts, friendly facts that you know, that multiply to get close to your answer and figuring out how close you can get to your answer. Right, mind's on. Let's engage in some prior learning. So we're going to recap from our previous lesson about simple interest. So our simple interest formula is I equals PRT, where I is the interest earned in dollars, P is the principal invested amount in dollars, the money that you start with, R is your interest rate per year expressed as a decimal, and T is your time in years. We remember that this is linear growth, so we're growing at a constant rate. We are adding the same amount every time. That's what we were doing last lesson, and we're now going to connect that to our next newer topic, which is compound interest. So let's explore some new concepts. As always, answering the question, when will I use this in real life? We are making connections and seeing patterns. And so compound interest and simple interest are things that happen around us all the time, particularly with money. And so we are making connections to those concepts and seeing what patterns arise. So examples of compound interest in our lives are most investments use compound interest to some degree. Our student loans, as well as credit card debt, are all compound interest. So first, we're going to figure out how we go from simple interest to compound interest. We're going to relate the two to understand what it is that we're talking about. So we're going to look at what happens when $1,000 is invested for 7 years at 5% simple interest. So this is the same as that we were doing last lesson. So we're going to make a table comparing this information so that we can see what's going on. We're comparing our years, our principal amount, our interest, and then our final amount. So for year one, our principal amount is $1,000. Our interest, we do 1,000 times 0.05 for our percent. So that equals $50. And therefore our total amount is 1,000 plus 50, which is $1,050. Our year two, our principal is still $1,000. Our interest earned is still $50, 5% of 1,000. And our total amount is now $1,050 plus $50, which equals $1,100. Year three, year four, year five, year six, and year seven, we calculate the exact same way. So our principal is always $1,000. Our interest is always $50. And therefore we just are adding $50 to our amount each year to increase up until the end of 7 years, it's $1,350. So that's how we calculate simple interest. We're adding the same amount every time. So this means that after 7 years, we have a total of $1,350, which means we earned $350 in interest. Okay, so what happens when we take $1,000 and invest it for 7 years at 5% interest compounded yearly? So now instead of doing simple interest, we're going to do compounding interest, which is our new concept. So again, we're going to compare our year to our principal, to our interest amount, to our final amount. So in year one, we are the same. Our principal is $1,000, how much we start with. Our interest is still calculated that it's 5% of that $1,000, which is $50. We add it together to get our final amount, and we have $1,050. But now in year two, everything changes with compounding interest. Now our principal is $1,050. We take the amount that we had in total at the end of our first year, and that's our new principal. So then when we do our 5% of our $1,050, our new interest is $50 and $52.50. So we add that to the amount of $1,050. And so we have $1,102.50. So already we've earned a little bit more because our principal had changed in year two. In year three, our principal changes yet again, because it's the amount that we had at the end of year two is what is now being invested in year three. So our principal is $1,102.50. So if we take 5% of $1,102.50, we now have our interest is $55.13, which we add to our amount, $1,102.50, to get a total of $1,157.63. And this is how we continue. So in year four, our principal is $1,157.63. We times that by 5% to get an interest of $57.88. We add that amount to our principal so that we now have a final amount of $1,215.51. Year five, again, our final amount from year four is our new principal. We times it by our 0.5 to get an interest amount. We add that interest amount to our principal amount. And so our amount at the end of year five is $1,276.28. Year six, that $1,276.28 is our new principal. Times it by 5% to get $63.81 as our interest. Add those two together, we get $1,340.10, which is our principal for year seven. So $1,340.10 times 5% is $67. Add that to our principal, we have $1,407.10. So after 7 years, we have a total of $1,407.10, which means we earned $407.10. So when we compare simple interest to compound interest, after 7 years of simple interest, which was our first calculation, we had a total of $1,350. So we earned $350. After 7 years of compound interest, which was our second calculation, we had a total of $1,407.10, which means we earned $407.10. So with compound interest, we earned $57.10 more just because it was compound interest. We didn't do anything else differently. We had the same interest rate, we had the same length of time, but because we were compounding our interest, we were making interest on the money that we already would make interest on. Therefore, we made more money. So compounding interest, now you can see, grows exponentially because we're making money on top of our money. So if there's a graph we have on our screen, and with our simple interest, well, there's no compounding. It is just linear. We're just increasing at a constant, steady rate. So we're just going up at the same amount every time. But at a compounding rate, we increase faster and faster and faster, where it has exponential growth. So you can see that at the beginning, after just a couple of years, it's not going to matter that much. But over time, because we're compounding, we are growing so much faster than if we would just do simple interest. So we need to remember that compound interest is exponential growth. So the definition of compound interest is such that interest is calculated on the principal and the earned interest. So that's what's really important, is that every time we earn money, it gets rolled into the principal, and then we're investing all of that together. So this is exponential growth. I like to think of it as free money from free money. And this is great for investments, but it's not helpful if you're borrowing, because it applies the same way indirectly, right? So if we're borrowing money, and that means that we're paying more and more if it's compounded interest. So then the question is, can we get more free money? I like free money. So we know that compound interest earns more than simple interest. But the more frequently we compound, the faster the interest adds up. So compounding is how often we are adding our interest back into our principal. So we can look at this graph on the screen, and we can see that we're comparing different compound rates. So this red line is if we compound once a year. So we compound yearly, and it's still growing faster than if it was linear, if it was straight line, but it's not super fast. If we compound monthly, so every month, we then have this blue line, which you can see grows faster than the red line. If we compound weekly, so we compound every week, then it's this green line, which is growing slightly faster than the blue line, which is growing faster than the red line. And if we compound daily, then you can see that that grows just even slightly faster than the weekly amount, which is growing faster than the monthly, which is growing faster than the yearly. So the more frequently we compound, the more interest we can earn. Again, this is applicable to if you're paying down debt, if you're paying off a loan, the more frequently you're compounded, the more interest you're going to end up paying. So compound frequency is something to remember. So the compounding period means the time frame in which compound interest is calculated. So compound periods are generally often less than a year. So the compound frequency is what you're going to see in a question. It's going to be what's coming up. You're going to notice in real life situations, and what the compounding periods per year, what that means. Annually means that it's once per year. Semi-annually means that it's twice per year. Quarterly means that it's 4 times per year. Monthly means that it's 12 times a year. Weekly means that it's 52 times a year. And daily means that it's 365 times a year. Again, we ignore leap years. We just do 365 for daily. So similar to what we were doing previously, but we also now have semi-annually and quarterly. There are a few more, but those are the ones we're going to focus on right now. So it's important to know this language so that you know how many compound periods are happening in your questions, in your situations. All right, so let's look at the compound interest formula. This is on page 2 of your IL book. So the compound interest formula is A equals P times 1 plus R over N all to the exponent NT. A is equal to your final amount. P is equal to your principal invested, so the amount of money that you start with. R is equal to your interest rate, expressed as a decimal, and N is the number of compounding periods per year, and T is your time in years. So I like this equation better. What's actually in your book is slightly different. We're going to look at it now, but I like this one because it breaks down the math that you need to do. So in the formula that's given in your booklet, there's math that you need to do before you get to your formula, but this tells you all the different parts. All right, so on page 2, what is actually given is, for your compounding interest, is A equals P times 1 plus I to the exponent N. Again, A is your final amount, P is your principal invested, so still the same, but your I is your interest rate as a decimal per compounding period, which is your interest rate as a decimal divided by your compounding periods per year. So what I like about the previous formula is that instead of having I and having to do this interest rate divided by compounding year, we do all of that in this one step. You can do either way, whatever makes more sense to you is totally fine. So that N in this one is the number of compounding periods in total. So again, in the previous formula that I'm going to be using, the number of compounding periods times the years is what I put in my formula so that I remember all the parts instead of just sometimes just having the one variable here at the end makes me forget that I need to times it by the number of compounding periods and not just just the time of years. So again, you can use both of these formulas. You're going to do either way. You're doing exactly the same thing. It's just a matter of where you put the information and what parts you need to remember. So comparing these two formulas, explicitly looking at them. So A is our final amount. It's exactly the same. P, our principal invested, again, exactly the same. So for R over N, I put it in my formula. I have the interest rate is your R expressed as a decimal, and N is the number of compounding periods. So I divide that into my formula, whereas in the formula in the booklet, it's I. They just give you I, and you need to do the calculation of your interest rate divided by your number of compound periods. But as you can see, that's exactly the same information. It's just a different way of writing it. NT, I do it as your number of compounding periods times your T in my formula, whereas in the booklet, they do your N is your number of compounding periods times your number of years, which they just do it separately, and then you have to put that final number into your formula. Again, it's exactly the same thing. It's just a different way of writing it down. And you can do it either way, whatever makes the most sense for you. Okay, so let's look at an example to figure out what it is that all of this means. So given a question, we have an amount of $4,000 is deposited into a savings account at a rate of 7% compounded monthly. Calculate the total balance after 5 years. So we have to figure out what we know and what we don't know. Question says calculate the total balance after 5 years. So we are looking for we're looking for our amount. Our P is equal to 4,000. That is the principal. That's the amount that we're starting with. And an R is equal to 7%, so 0.07. It's compounded monthly, so that's 12. And our time is 5 years. Because this is compounding, we have what's compounded monthly. We know that we're using our A equals P times 1 plus R over N, all to the exponent NT. I'm just going to continue with this formula because it expresses everything. But again, it is the same as what you have in your book. So inputting all of the information that we have that we've gathered, I like to gather it first so that I make sure that I have everything. So A is equal to 4,000 times 1 plus 0.07 divided by 12, all of that to the exponent of 12 times 5. Then I would do that math and simplify as much as I can. So A equals 4,000 times 1.00583, all to the exponent 60. A note about your decimals. If your decimal is more than 5 places, it can be smart to keep it into your calculator to make your calculation more accurate. I personally am struggling with the calculator that I have. I'm not as used to it, and so I make mistakes with it. So if you need to round, it's fine. I'll accept a rounded answer. Just know that having full calculation is the best way to get the most accurate answer, which is how computers do it, and how businesses will calculate things, is that they'll have the most precise, because they'll use a computer to do it, and therefore keep all the information, which if we write it out by hand, we lose information. So then if we calculate that, we end up with 5,670.50. So the total balance in the savings account after 5 years is $5,670.50. Again, we want to write a sentence so that we're interpreting. We know if we got to the end, we know if we are actually answering the question that we're asked. So as I said before, compounding is great for investments because we earn more money faster, but it also applies to loans and debts. So this example, we're going to look at how it applies to loans and debts. Xavier's credit card balance is $800 at the beginning of July with an interest rate of 19.99% compounded daily. He forgot to pay his bill until the next month. How much interest did he have to pay? So we're trying to figure out what we know and what we don't know. So we're trying to find the interest. That's what the question asks. How much interest did he have to pay? And we know that interest plus principal is equal to our total amount. So we're going to have to do a little bit more calculations, but we still need to find our amount so that we can then figure out what our interest is. So our principal is $800. That's what the credit card balance was. Our rate is 19.99%, which is equal to 0.1999. Our compounding period, is 365 because it is compounded daily. And our time is 31 out of 365 because it's July, is 31 days out of a total of the year, right? We have to, T is always in years. So 31 out of 365 days is how much of a year it is. So we take our formula and we plug in our values that we know. So A is equal to 800 times 1 plus 0.1999 divided by 365, all to the exponent of 365, our compounding period, times 31 divided by 365, which is our time that we had. So we end up with A equals 800 times 1.00054 to the exponent 31, which is equal to $813.69. So how we answered our question is the question is, how much interest did he have to pay? Did he have to pay $813.69? No, that's not all interest. So we need to calculate what the interest amount is. So the interest amount is A equal to principal plus our interest. So our interest is found by doing our total amount, subtracting our principal. So $813.69, take away 800 is $13.39. Sorry, 69 cents, that was just a typo. Happens. Okay, so Xavier has to pay $13.69 in interest for his credit card balance that he carried in July. Okay. So third example, the principal of $250 is invested at $12.5% is compounded quarterly for 6 years. Question is, calculate the cumulative interest at the end of each year. So because we are calculating the interest, we know that we are looking for I, which is our total amount, subtracting our principal. And then we need to calculate what our total amount is so that we can figure out what our principal is. So, our interest is. Our principal is $250. Our rate is 12.5, so 0.125. Our compounding periods, our N is 4 because it's compounded quarterly, and our time is 6 years which is already in years. So the question actually asks at the end of each year. So not at the end of the total years, but at the end of each year. So our time actually we're going to keep as T instead of putting at 6. That would tell us what is the amount of the total of all of the years. It's important to make sure that you're reading what the question asks. So we put our amount in our formula. So 250 times 1 plus 0.125 divided by 4, all to the exponent 4 times T, because we're going to be calculating for each year. So we're going to do a table to show that information. So in year 1, we put in 1 for our T, and then we get $282.75. So our interest, because we subtract our principal from $282.75, is actually $32.75. So at the end of year 2, now we're just changing it so that we put a 2 in our equation instead of a 1, because we're trying to figure out what the end of year 2 is. So our total amount is $319.79. Our interest is $69.79. And then we continue to do that same thing throughout our process so that we can figure out what the total amount of interest is that we've accumulated over each year. So it's really important to make sure that you know what the question is asking. Okay, so then part B of this question is draw a graph to show the growth of this investment. So your amount is according to your years, and you can see that we're just as increasing and that it's starting to increase faster and faster. I use the Desmos graphing calculator online, and I'd strongly encourage doing that. If you want to do it digitally, you can also do it by hand, and that is totally fine. So then part C says use the graph to determine when the accumulated is $100. So how we figure that out is we look at our graph and we say, okay, 100 is how much interest that we've accumulated. When did that happen? So then we go over to our graph and we say, okay, when does our line hit 100? And that happens at 2.75 years. So we use our graph by going over from our interest amount, and then down to figure out how many years is when that happens. So our accumulated interest is $100 after 2.75 years. Okay, so now if you wanted to pause the video and go to page 13 of your IEL book and answer those questions 1 through 3, those support questions will help you with these topics to practice. Okay, let's consolidate what it has been that we've learned today. So the highlights of lesson 7 are that compound interest grows exponentially and the pattern increases or decreases at a constant ratio. Our formula is A equals P times 1 plus R over N all to the exponent NT, where A is our final amount in dollars, P is our principal in dollars, R is your interest rate expressed as a decimal, T is our time in years, and N is our number of compound periods. Our interest is calculated by doing I equals A take away P. So our final amount to take away our principal is how we calculate our interest dollar amount. So looking at our success criteria, if you can identify the principal, the interest rate, the compounding periods, and the time in order to find a final amount, that's what we're hoping you can do from a question, to be able to identify all of those different parts. And part 2 is you can graph compound interest growth. So you can relate your time to your amount of interest and graph that to see that it's exponential growth. Okay, so let's do some more practice questions and see to make sure that we can identify all those parts. So if a person invests $2,500, 5.75% for 7 years compounded annually, calculate the investment at maturity. So at maturity means calculate it when it is over, when it is done. So that means that we are looking for A is the amount that we're trying to find because we're asking for the investment at maturity. So our principal is 2,500. Our rate is 5.75%, which 3/4 is 0.75. So that's 0.0575. Our T is equal to 7 years. And our N, our compounding, is 1 because we're compounding annually. So that's happening once per year. So our formula is A equals P times 1 plus R over N all to the exponent NT. When your exam comes around, I will give you formulas sheets with all of your formulas. You'll need to know which one to apply, but you do not need to memorize these. That is fine. If you don't have them memorized, you can look them up. That is totally reasonable. So then we put in our information that we know. So our principal is 2,500. 1 plus our rate is 0.0575 divided by our N, which is 1, compounding annually. And then our time is 1 times 7. So 2,500, 0.0575 divided by 1 is just 0.0575. So adding 1 to that is 1.0575. And then to the exponent, 1 times 7 is 7. So then using a calculator, we have 2,500. I'm just doing this on my own calculator. You can do it on your calculator. Make sure that you know how to raise your base to an exponent 7. That's back at the exponential, the exponent laws and exponential functions. So that equals $3,697.45. So the investment worth $3,697.45 at the end. Okay, that's how we do that one. Next question. A person has $3,500 to invest at 5.75% compounded quarterly for 3 years. Calculate the amount due. So it's asking us to calculate how much we're going to have at the end. That's what amount due means. So again, we're looking for our A. So our principal is equal to 3,500. Our rate is 5.75%, which is equal to 0.0575. Our T is equal to 3, and our N is equal to 4 because it's compounded quarterly. So A is equal to P times 1 plus R over N times NT. I always like to write my full formula out just so that I make sure that I am not missing anything, and that if I make a mistake there, then I know that I made a mistake in my formula by just miswriting it, or if I made a mistake with my calculations or my understanding. So this is the place where I ask you to write all of your steps to show what your understanding is, and then I can catch where you might be making a mistake. I am lazy, so I understand being lazy and not wanting to write it all out, but it's going to make your life easier as you're learning. So it makes sense to do that now. So when I fill in all my values, I have 3,500 times 1 plus 0.0575 divided by 4, all to the exponent 4 times 3. So then I'm going to calculate what I can. Again, on your calculator, you can leave your division and do it all in one step, or you can break it up depending on your calculator and what is easiest for you to track. I try to keep my numbers in my calculator as much as I can, but sometimes that just can't happen. So we end up with 3,500 times 1 plus 0.0144 also the exponent 12. Also, using the Desmos calculator, they have a scientific calculator, which can be really helpful to put in because you can put in all of your values and you can see exactly what's going on. That is another strategy, another tool to use. So then we calculate this on our calculator and we end up with $4,153.85. So the question B asks, calculate the interest earned on the investment. So we're trying to find the interest, which is equal to our amount, take away our principal, right? The amount is our total amount, principal is how much we invested. So how much is interest, how much is extra? So our amount is $4,153.85. Take away $3,500. So that is equal to $653.85. And that is your interest earned. So the interest earned is $653.85. All right, next question. Person wants to invest $300 for 10 years and has two options. Which plan should the person choose? So plan A is 3.2% compounded semi-annually, and plan B is 2.7% compounded weekly. So we need to figure out which of these two options is the best. Often you're going to be provided with multiple options in life. So being able to figure out and compare them is really, really useful. So for this question, we're going to first look at plan A. In this type of question, when you have multiple things going on, being able to organize your information is really, really helpful in order for me to understand that you understand what you're doing. So I'm going to do these two things separately, side by side, so that I know what's going on and keeping myself organized. So first, we're going to start with plan A. Because we want to find out the amount that we're having in total, right? So to figure out which plan we should choose, we want to figure out how much money each are making. So we're looking for our A. P is 300. That's how much we're investing. R for plan A is 3.2%, which is equal to 0.032. T is equal to 10 years. And N is equal to 2 because it's semi-annually in plan A. So then our formula, A equals P times 1 plus R over N, also the exponent NT. Also writing it out over and over helps you remember it. So then we put in our values. So 3,000 times 1 plus 0.032 divided by 2, also the exponent 2 times 10. So 3,000 equals 0.032 divided by 2 is 0.16. So plus 1 is 1.016, all to the exponent 20. So depending on what you are comfortable with, and what you write down is going to be different. Which steps you write down, you can write down all the steps when you're doing calculations, or you can write down some of the steps. Writing down all the steps means that it's easier for me to find out where you may have made a mistake. But if something seems obvious to you, like 2 times 10, you can just write 20 if that makes sense to you. Do what makes sense to you, but know that the less information you give me, the harder it is for me to figure out where you may have gone wrong. So for plan A, we end up having a final amount of $412.90. So that's what plan equals. So plan B, let's look at our A is still what we're looking for. Our principal P is still 300. We're still investing $300. Our R for Plan B is 2.7%, which is equal to 0.027. Our T is still 10. We're still doing it for 10 years. But our N, if we're compounding weekly, is 52. So our N is 52. So A is equal to P times 1 plus R over N to the exponent NT, which is equal to 300 times 1 plus 0.027 over 52 times 52 times 10. So then we calculate this, 300 times 1 plus 0.027 divided by 52 is 0.00052. So adding that to 1, we have 1.00052, all to the exponent 520. We calculate that. And we get $392.96. So Plan B gets us $392.96 as our final amount. So now we have to think, are we finished? Have we answered the question? No, the question said was, which plan should the person choose? So we haven't answered that question. I don't know what you think the person should choose between these two options. So you need to still answer the question. So assuming that when a person invests money, they want to earn more money. So I would advise the person should choose Plan A because it earns them more money. It is good, again, to write this full sentence because I know you answer the question, the Plan A is what they should choose, but you also give me the reason why. So then if a situation happens that you make a mistake in your calculation, or you say that they should choose Plan A because it earns more money, but we're actually having a credit card question, and so we barely actually want to have less money, then I can figure out where your mistake is. So again, giving me your reason for your answer is really, really helpful to justify your answer, because that's what matters in life. So yes, the numbers are important, but also the interpretation and the justification of your decision is really what helps you overall. So that's the skill that we're learning in terms of those making connections and using that information, is that yes, doing all the calculations is good and important, but then justifying why that's relevant to your situation is what's really quite useful. Okay, so we have some time for a little bit of an extra practice. We have one more question we can do. So Shu Ying invested $750 at 5% per year, simple interest. Her sister, Shu Jin, invested $750 years at 5% per year, compounded annually. Who earns more interest? So this is similar to our last question, but now instead of comparing different compounding frequency and interest rates, we're comparing simple interest to compound interest. So again, we're going to break it up, organize our information. So Shu Ying is simple interest. Shu Jin is compound interest. So for simple interest, our formula we remember is I equals PRT. So we're trying to find out who earns more interest. So I is our interest, what we're looking for. Our principal is 750. Our rate is 0.05 because it's 5%. And our time, our question doesn't say time. I made that mistake. So we're just going to say our time is 1 year. We're going to assume that it's 1 year. So I equals PRT is 750 times 0.05 times 1, which is equal to 750 times 0.5 is equal to $37.50. So Shu Ying earns $37.50 in interest. So then Shu Jin, let's figure out what she earns for compound interest. So we're still looking for interest, but interest we know we have to do our amount to take away our principal. So we still need to find our amount. So our principal is 750, the same amount. Our rate is 0.05. Our compounding is 1 because it's compounding 1, and our time is 1. So if we do A equals P times 1 plus and over, sorry. See, this is why we write it out so that we know where we make mistakes. P times 1 plus R for N times NT is equal to P times 1 plus 0.05 over 1 to 1 times 1. So our P is 750. So 750 times 1.05 all to the exponent 1 is going to give us $787.50. So our I is equal to $787.50. Take away 750, which is equal to $37.50. So if it's only for 1 year, it doesn't matter. But say, let's do the same example and do for 10 years. So I equals PRT, where T is now 10. So 750 for Shu Ying times 0.05 times 10 is going to be 750 times 0.05 times 10 is $375. If we say T is for 10 years for compounding interest, so A is equal to 750 times 1 plus 0.05 compounded once, the exponent 10. So 750 times 1 plus 0.05 to the exponent 10 times 750 is equal to $1,221.67, which take away our principal of 750, which means that our interest earned is $471.67. So simple interest and compound interest, you can see, doesn't make much difference in the short, but makes much more of a difference in the long run. So that's why it makes more sense to compound in the long run if you're investing. All right, thanks so much for joining me today. As always, you can contact me the usual methods through phone, through my email at bronwyn.slate@nec.on.ca, or through Facebook at vslate Wahsa. I hope you have a great day and which.